In this video, we're going to have a look at something called compound interest. This is where we take a percentage increase or decrease and apply it more than once. So, in this example, Andy invests £220 in a bank account which pays 5% interest. This means that his original amount, which is obviously 100%, has been increased by 5%. This means that what he's now left with is 105% of his original investment. What I need to do to that is turn it into a decimal, which is 1.05. Now what we're going to do next is we're going to take his original amount, which was 220, and I'm going to multiply it by the decimal multiplier. So 220 times 1.05 will tell me that Andy has £231 in his bank account at the end of the first year. This is actually the compound interest part of this problem. How much will he have after 5 years? So if we set this problem up like before, he has £220 and it increases by 1.05, 5%. Now that's just the first year. I need to do this for 1, 2, 3, 4 additional years, making 5 years in total. So there's my original amount increased by 5%. There it is after the second year, the third year, the fourth year, and the fifth year. Now some of you should recognize that what we've got here is a bit of a pattern. If I'm multiplying by the same number 5 times, then I can simplify this to just his original amount, £220, times 1.05, the decimal multiplier, to the power of 5, because it's invested for 5 years. When I do this calculation, it will give me the amount in Andy's bank account at the end of the 5 years, which is actually £280, 78p. And because this is money, I always leave it to 2 decimal places. In this second example, we're looking at a car which has been depreciated in value. What this word means is it means it's decreased in value. So it's gone down by 12% a year. His original amount was 100% and it's decreased by 12%. This means that his car is now worth 88% the original value. As a decimal, this is 0.88. So at the end of the first year, I'm going to take the original amount, £8,000, and I'm going to multiply this by 0.88, and this will tell me that at the end of the first year his car is worth £7,040. After 3 years, I'm going to modify my calculation slightly. It's £8,000, the original amount, and that's being multiplied by 0.88, which works out 88% of the original amount, and I want this to apply 3 times because it's 3 years. When I do this calculation, I work out that the price of his car at the end of the 3 years is £5,451, 78p. Here are 2 questions for you to have a go at. Try these out. Remember the things that we've looked at in the first 2 examples. Hit play when you're ready for me to go through the answers. Okay, so George has invested £350 in his bank account. It pays 3% interest. So to work this one out, I'm going to take the original amount, which is £350. I'm going to times it by the decimal multiplier 1.03, and this tells me that at the end of the first year, George has £360, 50p left in his bank. If I'm applying this same increase for 7 years, I'm going to do £350 times 1.03 to the power of 7. This tells me that at the end of 7 years, George has in his bank account £430, 46p. In question 2, the value of a car depreciates by 15% each year, so I'm actually looking for 85% of the original value. So the car originally was £35,000. I now need to work out 85% of it, and I need to do that for a total of 5 years. It's 5 years because the car was bought in 2010, sold in 2015. And when I type all this into my calculator, I get the new price of the car, which is £15,529.67. Well done if you got both of those questions correct. Thanks for watching.